The next thing that we're going to do is we're going to concern ourselves with this datum C. Now datum C has to be, where does it call it out? Right here. It says that this side needs to be square to A and B within 0.03 of an inch. So we need to concern ourselves with that. What we also need to concern ourselves with is making sure we've got the proper surface. So if you look at this part, this is datum A, this is datum D. That means that this side over here is going to be datum C. So we need to make sure that we get the right side when we do this. Now, the way that we're going to set this up is we're going to take our vise, and this is the moving jaw. This is the fixed jaw. And we're going to use those high parallels to set that part on. We're going to let the part itself hang off the side of the vise. So this is looking down. And datum A is on the bottom. Datum D should go against the fixed jaw, and we're going to periphery mill this surface right here. What we're looking for is this surface to come up perpendicular within 0.003 to datum A and datum B. Now, remember in the beginning, we talked about datum B. Datum B is actually the width of this part. So if we have one side square, the other side's going to be square because these two sides are parallel to each other. So now I want to take my part, I'm going to put it into the mill, I'm going to let it hang out over the edge just a little bit. Tighten this up good in the vise, take my soft hammer, smack it down so that it's tight on top of these parallels. And I'm going to come over, bring my cutter in close to my workpiece. I'm going to drop the quill down. Now with the quill, I don't want to have my quill hanging out too far because I lose a lot of rigidity when I do that. Bring the cutter over close to the edge of the part. We're going to turn it on. Come up against the side of the part. Back off. And let's take, about 10-20 thousandths off of here. This is our roughing cut. Just going to take another 2 or 3 thousandths off. And climb cut this in the other direction. Nice and smooth. And we'll get a real nice finish out of this. Look at your finish. Looks nice and pretty. We'll move this back out of the way. Incidentally, when you go to clean up, don't pick up these chips with the vacuum cleaner. They will clog the hose. Now we can inspect this part and deburr this part. Alternatively, we can set the part in the vise this way, indicate the side of the part in, and face mill Datum C as well. Another method we can use to square Datum C up to Datum A and D is to use the angle plate, clamp our part to it, and indicate this side. So now let's check this side for square. So first we're going to take side A, side D, and we're going to put them against our magnetic V block, lock that into place, and we're going to indicate across the top of the part. And in this case, we see that, oh, there's about a thousandths run out on that. But you remember the print said Datum B. It didn't say Datum D. Now Datum B is this entire width. So to ensure that this part is square to that Datum B, we're going to take the part out of the V block, take it away from Datum D, and go to the opposite side so that we've got Datum A locked in on one side and the side opposite D on the other side. And this is going to assure that we are square to Datum B. And in this direction, we see maybe a half a thousandths run out. So we know that this is well within tolerance. We have completed 5 sides of this block now, and we're going to complete the 6th side now. So the 6th side we're looking at is this side right here. Notice there's a 250 dimension. It's a 2-place decimal, which means that tolerance on that is plus or minus 15 thousandths. But up here, it says that this surface has to be parallel within 3 thousandths to Datum C. So it has to be parallel to this side within 3 thousandths. Now, the process to mill this is very similar to the process that we used to mill Datum C. So we're just going to go ahead and set that up in the vise and mill that side off just the same way. So now that we have 5 sides of this part done, last thing to do is finish off that 6th side. Now, we can do this a number of ways. We can set the part in the vise in this fashion and mill off this surface and make it parallel to this surface, or we can flip the part around and have it hang off the edge of the vise. And bring this into size in this fashion using the periphery of the cutter. Make sure the parallels are down tight and you crank down on that vise. So now we're ready to go ahead and put our cutter in and mill that off. I put my end mill into the collet, got my part clamped up. I brought the cutter down so that most of the face of the cutter, let's adjust this a little bit, the face of this cutter now is going to span this entire part, and we're going to take, remember, our heavier cuts are always going to be conventional cuts. Our finished cut is going to be a climb cut of about 2 or 3 thousandths on the way back. Just for starts, I'm going to take about 20 thousandths off this part. Lock my table down. Take my cut across here. loosen my locks. And I'm going to take 2 or 3 thousandths off of this. And if we want, we can zero out our digital readout in the X direction, so that we know where we want to end up. Now, given that our setup is good, we can just go ahead and measure this part. And I see that I am measuring 2 inches, 640 thousandths. So I've got 140 thousandths to come off of this. I'm using dial calipers for this because my tolerance is plus or minus 15. So we've got 140 to take off of this. Let's go ahead and take 70 thousandths off of this. Back to the other side. I'm going to crank this up to 135. And then I'll take that last 5 thousandths off on the way back. This in the last 5 thousandths. Lock my table down. Come back across. Lift the cutter back up out of the way, and we're going to measure that. And according to my dial calipers here, it is right on the money. So we know that our length is 2.5 inches, which we already checked using our dial calipers. We're going to take side C, set it down on the surface plate, move it around a little bit, make sure it's sitting flat. You'll be able to feel it if something's not quite right with this. We're going to put it up underneath our indicator. And take the part and roll that underneath. And we should see less than 3 thousandths. In this case, I'm seeing a reading which looks to be about 1/1000th of an inch. I'm seeing about 1/1000th of an inch out of parallel, and that's perfectly fine. We've got 3 thousandths to work with. So now we have 6 sides of this done. We're ready to move on to cutting the steps.